Welcome to Dr. Mercola's Cellular Wisdom. Stay informed with quick, easy-to-listen summaries of our latest articles, perfect for when you're on the go. No reading required. Subscribe for free at mercola.com for the latest health insights.
Hello, and welcome to Dr. Mercola's Cellular Wisdom. I'm Ethan Foster, and today we're taking a close look at artificial food dyes, especially Red 40, Red 3, Yellow 5, Yellow 6, Blue 1, and their impact on health. We'll examine why these petroleum-derived additives are still in more than 36,000 U.S. processed foods, and what the latest data reveal about their risks.
I'm Alara Sky, and this discussion matters because those bright colors in chips, cereals, drinks, medicines, and even children's vitamins offer no nutritional value. Red 40 alone colors everything from snack cakes to sports beverages, while Red 3, a dye the FDA acknowledged as a carcinogen decades ago, still appears in about 8,000 products. Understanding why that persists is vital for informed choices.
Let's start with prevalence. Over 3 decades ago, the FDA said Red 3 caused thyroid tumors in animals, yet it stayed on shelves. Only in January 2025 did the agency finally ban Red 3 in foods, giving manufacturers until January 2027 to phase it out. Meanwhile, Red 40 remains unrestricted despite its wide exposure, especially among children. Why has action been so slow?
The core issue is regulatory inertia. Safety thresholds for these dyes rely on toxicology studies from the 1970s and 1980s. Those limits don't reflect current consumption patterns, where kids might drink a dyed sports beverage, eat colored cereal, and take a vividly tinted cough syrup all in one day. Updated research shows that cumulative exposure can exceed what newer data deems safe.
Beyond cancer concerns, parents often notice behavioral shifts. What does the evidence say about links between synthetic dyes and neurobehavior?
Multiple randomized controlled trials demonstrate that Red 40, Yellow 5, Yellow 6, and Blue 1 can increase hyperactivity, restlessness, and attention difficulties in children. California's Office of Environmental Health Hazard Assessment concluded in 2021 that even small, legally permitted amounts impair working memory and impulse control, with stronger effects in kids already dealing with ADHD.
An underlying question is why these dyes exist at all if they serve no nutritional function. Are we essentially eating color for marketing's sake?
Exactly. As cardiologist Dariush Mozaffarian put it, if a food needs a dye, maybe we shouldn't be eating it. The dyes merely make processed foods visually striking, boosting sales, especially among children attracted to bright hues. They're cost-effective for manufacturers, but they shift the hidden costs to public health.
Let's go back to Red 3. The FDA banned it from cosmetics in 1990, but took 35 years to extend that ban to foods. What finally tipped the scale?
Persistent advocacy and accumulating data. Consumer groups like the Center for Science and the Public Interest petitioned repeatedly, highlighting carcinogenic evidence and child exposure. Coupled with mounting state-level bills and a broader federal interest in chronic disease prevention, the FDA could no longer ignore the inconsistency of allowing a known carcinogen in foods while barring it from lipstick.
You mentioned state action. How does U.S. policy compare with Europe, and are states moving faster than Washington?
Europe requires warning labels on products containing certain dyes, stating they may affect activity and attention in children. That prompted many multinational brands to reformulate European versions with natural pigments like paprika and beet juice. In the U.S., identical products often keep petroleum dyes and carry no warnings. At home, more than a dozen states, from California to New York, are drafting bills to restrict dyes ahead of federal moves.
Funding cuts can hinder progress. In early 2025, the NIH announced reductions to dye-related research, sparking lawsuits from 22 states. How might those cuts affect future regulation?
Reduced funding slows the generation of contemporary safety data, which regulators rely on for risk assessments. Without robust current studies, it becomes harder to demonstrate harm to the legal standard required for nationwide bans. That delay favors industry status quo, prolonging consumer exposure.
The April 2024 CSPI report also flagged other dyes. What did it reveal about Blue 1, Blue 2, Green 3, and the yellows?
Blue 1 is linked to neurotoxicity and rare allergic reactions. Blue 2 showed brain tumors in male rats, and green 3 was tied to bladder and testes tumors in an early 1980s study. Yellow 5 and yellow 6 may be contaminated with carcinogenic byproducts and can provoke hypersensitivity or severe allergies. Despite these findings, all remain FDA approved without mandatory disclosure of contaminant levels.
Let's circle back to the California findings. How did the OEHHA quantify behavioral change? And what does that mean for everyday families?
The agency analyzed clinical trials measuring parent and teacher-rated behavior. They found statistically significant increases in hyperactivity scores after dye exposure. Importantly, the doses causing effects were well within ranges children can reach on a normal diet. For families, it means even conscientious monitoring can't ensure safety, because exact dye quantities are not listed on labels.
A 2024 peer-reviewed overview in the International Journal of Environmental Research and Public Health broadened the scope beyond behavior. What additional risks did it highlight?
The review linked synthetic dyes to allergic reactions, gastrointestinal distress, respiratory problems, DNA damage, and potential heavy metal contamination with mercury, arsenic, cadmium, and lead. It also noted that some children's cough syrups can deliver nearly 3 times the FDA's acceptable daily intake for Red 40 in a single dose, illustrating that medicines, not just foods, contribute significantly to exposure.
Parents listening may wonder what concrete actions they can take today. Let's outline practical steps.
First, read every ingredient list. Terms like FD and C Red 40 or Yellow 5 signal synthetic dyes. Second, choose dye-free alternatives or whole foods. Organic and store brands often skip artificial colors. Third, make it a family mission. Involve kids in spotting and swapping products, turning dye elimination into a shared goal rather than a restriction.
Before we wrap, let's tackle a brief FAQ. What exactly are synthetic food dyes, and where do they hide?
They're petroleum-derived chemicals used purely for color. You'll find them in snacks, cereals, beverages, ice pops, pickles, medications, and chewable vitamins. Over 36,000 processed foods in the U.S. alone.
What are the primary health risks?
Behavioral issues in children, allergic reactions, potential carcinogenicity, especially with Red 3 and contaminants in yellow dyes, and possible heavy metal exposure.
Why are they still legal here?
Because current U.S. regulations require conclusive proof of harm before removal, rather than proof of safety before approval, and most safety data are outdated.
How do other countries handle them?
Europe mandates warning labels, driving reformulation with natural colors, whereas U.S. products continue using petroleum dyes without equivalent labeling.
Final takeaway. Eliminating artificial food dyes is a straightforward step toward reducing unnecessary health risks, especially for children. Thank you, Alara, for the insights. And thank you to our listeners for joining us on Dr. Mercola's Cellular Wisdom. We'll be back soon with more evidence-based discussions to support your well-being.
Thanks for watching. Subscribe now and click the notification bell so you never miss an update. See you in the next video.